Let us enjoy the journey of learning. I am Anil Kumar, and in this video, I am going to share with you a test question to prepare for calculus. The function f of x is a cubic function 1 over 3x cubed plus half x squared plus kx plus 5, and it has a local maximum and a local minimum. The local maximum is at x equals to minus 3. Two parts. First is find the value of k, which is not given to you in the function. And part B is find the point where the graph of f has a minimum. Right, so let's change this. So find a point where the graph of f has a minimum. Right, so we are given the maximum, so that's the second thing which we need to find. So let's try to work on it. Basic concept is that at maximum or at minimum, the derivative should be what? The derivative should be 0. Right? So first thing is we need to find the derivative. Great. So let's begin with the function itself, which is f of x equals to 1 by 3 x cubed plus half x squared plus kx plus 5. Derivative applying the power rule will give 1 by 3 times 3x squared plus half times 2x plus k. Let's simplify this. So we get here x squared plus x plus k, right? Relatively simple derivative. And now we want to find the value of k, and for that we are given a condition that the local maximum is at x equals to minus 3. So the condition is that local maximum at x equals to minus 3. So it means that the derivative of the function at minus 3 should be equal to 0. That is what it means, right? So so the derivative is minus 3 means let's substitute minus 3 for x and see what. So f of minus 3 equals to 0. Substituting minus 3, we get minus 3 square plus minus 3 plus k, right? Rearrange. So we have 0 equals to 9 minus 3 plus k, which is 6 plus k, or the value of k is minus 6. Right? So we got the value of k. So that really means that we can now write the function f of x as 1 over 3 x cubed plus half x squared plus k is minus 6. So we'll write minus 6 here, right? Minus 6x plus 5. Perfect. So that is what the function is. And we found the value of k as minus 6. Correct. Let's do the second part on a fresh page. So we need to find the point where the graph of f has a minimum, right? This is a cubic function, positive leading coefficient. So something like this, right? So we already know that this point where it was a maximum, it was at x equals to minus 3. We need to now find the point where it was minimum. So what we can do here is again find the derivative. We could use the derivative found earlier also. So let me rewrite the function once again. So we have the function as k is minus 6. Now we know it, right? So the derivative of this particular function is going to be 3 times 1/3 x squared, 2 times half, which is 1, so we get x. And here we get minus 6. We want this to be 0. That's what we need. And we need to find the value of x. since we are looking for the minimum now. So means horizontal tangent. That's what the concept is. So this equation is relatively simple. We can factor product of 1 and product of minus 6 and sum of 1. So that means 3 and 2 can work, right? Plus 3 and x equals to minus 2. I mean x minus 2, correct? So that gives us 2 points. One is x equals to minus 3, the other one is x equals to 2. So we already know that at minus 3 we have a maximum. So the other point is minimum, right? So we can say we need to find the point. So we can now plug in 2 and find the value also, right? So if I plug in 2, we get 1 over 3, 2 cubed plus half 2 square minus 6 times 2 plus 5. Okay. So that will give us the y value, right? So we can calculate this y value, 8 over 3, right? So we have 8 over 3 plus 4 over 2 is 2, right? Minus 12 plus 5. So that is, let's add them up. So we have 5 plus 2 minus 12, and then to this we'll add 8 over 3. And what we get is minus 7 by 3. So in this particular question, since we are already given that the graph has a maximum and a minimum, and there are only two critical points, so we really do not have to verify that this is a minimum, right? However, you can verify this as a minimum by many different techniques. One of them is to find the second derivative, right? So let's find the second derivative just to confirm. So second derivative will be 2x plus 1. And at this point, which we figured out as 2, this was x equals to 2. If I find the value at 2, we get 2 times 2 plus 1, which is 5. And since it is greater than 0, so it is concave upright. That means it is a minimum, right? So as you can also see here, concave up means minimum, and that is how you're going to verify. So you could verify and confirm that yes, at this particular point, which is for us 2 and minus 7 over 3, we have local minimum for this particular function. So I hope that is absolutely clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.